Welcome to Fascinating Frontiers, episode 74, for May 19th, 2026. Here's what's happening in space and science today. A joint European-Chinese spacecraft is now heading out to capture the first X-ray views of the invisible boundary where the solar wind slams into our planet's magnetic shield. A Vega C rocket lifted off from French Guiana, carrying the SMILE spacecraft, a joint mission between ESA and the Chinese Academy of Sciences. The satellite will use X-ray and ultraviolet instruments to observe how the solar wind interacts with Earth's magnetosphere and drives space weather. The rocket's final liquid stage performed a controlled burn to place the spacecraft on its correct trajectory after solid motor ascent. Mission teams confirmed solar array deployment and initial health checks shortly after separation. Engineers chose a highly elliptical orbit so the spacecraft can linger in the key interaction zones for extended periods. With fresh data on how the solar wind shapes our protective shield, we turn to the vehicle that may one day carry humans farther into that same environment. SpaceX has updated the target date for the next Starship test flight to no earlier than Thursday. The mission will continue gathering data on the vehicle's heat shield, engines, and landing systems ahead of future crewed and cargo goals. Focus remains on heat shield performance, engine reliability, and landing system data. Continued progress toward future crewed and cargo objectives stays the priority through this integrated test flight. While Starship pushes hardware limits, a much simpler alignment is already visible in evening skies right now. Observers can spot the moon positioned near Venus low in the west after sunset, with Jupiter higher up in the same constellation. The arrangement offers a clear line of three bright objects spanning Gemini for the next several evenings. Sky watching like this often sparks questions about how we protect both astronauts and satellites from the very space environment we're observing. Researchers have developed a NAND flash variant that uses ferroelectric materials to retain data without constant power. The design targets the extreme radiation and temperature swings encountered on long-duration missions beyond Earth orbit. Aims to reduce mass and power penalties on long-duration spacecraft. Another advance tackles radiation from a different angle, by turning the battery itself into part of the shield. A new cell chemistry improves energy storage while adding shielding against charged particles in deep space. The breakthrough could reduce mass penalties for protective systems on crewed missions. Hardware and protection stories naturally lead to questions about international partnerships that will supply those future missions. Agency officials have opened discussions with Taiwanese partners to explore contributions to upcoming Artemis-related lunar activities. The talks focus on potential hardware, tracking support, and scientific instruments. The Society's archive shows how British engineers and writers shaped early concepts for rockets, satellites, and interplanetary travel. Its work continues to influence current national efforts in small satellite and propulsion research. Local authorities launched a program of awards, funding announcements, and an air show to boost regional aerospace activity. The events highlight growing interest in satellite manufacturing and education programs. Users are comparing established planetarium software against newer apps that factor in current atmospheric conditions and satellite passes. The discussion highlights demand for integrated lists of targets, occultations, and transits tailored to a specific location and time. Now, here's something that blew my mind when I looked into it. Earth's magnetic field stretches into space far enough to enclose a volume larger than the planet itself. Yet the solar wind constantly presses against it like an invisible river. If you could ride outward with a packet of charged particles leaving the sun, you would cover the distance to Earth in roughly 4 days while traveling at speeds between 400 and 800 kilometers per second. At that velocity, the wind carries enough momentum to compress the dayside magnetosphere to about 60,000 kilometers from Earth's center on average, while stretching the night side into a long tail that reaches well beyond the moon. The boundary itself is not a solid wall. It is a thin current sheet where magnetic fields from the sun and Earth reconnect, allowing some particles to leak inward and power the aurora. Scientists can measure the exact location of this boundary with spacecraft, but they still cannot explain why reconnection events sometimes trigger global storms and sometimes fizzle with little effect. What hidden property of the incoming solar wind decides which outcome occurs? Keep an eye on updates from the SMILE mission as it settles into its highly elliptical orbit and begins its first systematic observations. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through